Electrophilic aromatic substitution reactions of phenol. Phenol is with a OH group, correct? Due to two electron pairs on oxygen atom, it is an orthopara director. And when you are treating with the dilute HNO3, you will be getting here OH group here, NO2 either at ortho position or at para position. Exactly, because OH is orthopara director. Fine. What are the specialties of this? Very low temperature is required. No need of any high temperature. Just you need dilute HNO3. And the specialty is this is with low boiling point and this is with high boiling point. It is having intramolecular hydrogen bonding and this is with intermolecular hydrogen bonding. Intramolecular hydrogen bonding causes the boiling point to be low and intermolecular hydrogen bonding causes the boiling point to be more. Fine. So you can use steam distillation technique. It is steam volatile orthonitrophenol. Correct. Now, if we use concentrated HNO3, same phenol with concentrated HNO3, you will be getting here. Here OH group, NO2 groups will be here. When three NO2 groups are at second, fourth, and sixth, trinitrophenol. 2,4,6 trinitrophenol is called picric acid. Very, very, very special. But the yield is not so high, yield is poor. So we'll go with one best method. First phenol is treated with, this is phenol. No? Phenol is first treated with a concentrated H2SO4, which gives you OH group and two SO3H groups at ortho and para position. Concentrated sulfuric acid gives you phenol 2,4-disulfonic acid. This is 1, 2, 3, 4 phenol 2,4-disulfonic acid. Then you treat with concentrated HNO3. If you are treating like this, you will be getting this compound. Fine. Electrophilic aromatic substitution reactions we are doing for phenols. One more reaction you can take, that is bromination. Phenol, if you are taking bromine in the presence of carbon disulfide or chloroform, a very, 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 very low polar molecules, you will be getting OH group here, bromine, and OH group para position bromine. Correct. So there is no need of any anhydrous AlCl3 or anhydrous FeCl3 because OH group is very, very, very dominant, very strong activating group. That's why we don't need any anhydrous groups. But if you treat the same with bromine and water, you will be getting here OH here, 3 bromines. A white precipitate 2,4,6 tribromophenol. A white precipitate of 2,4,6 tribromophenol is formed when you are treating with bromine and water. These two are the important electrophilic aromatic substitutions.